Hello and welcome to this new video from CircuitDigest. Today, in this video, we'll be testing this boost converter. It is a simple 30-watt boost converter which has been created using 555 IC. You can see that there are very few components in this converter, and the main heart of the system is this 555 IC. We'll come back to the making of the circuit later. Working of a boost converter. This is the basic circuit of a boost converter. In this converter, we have a voltage source, our inductor, which is basically the heart of the system. We have a switch, a diode, capacitor and load. Now how the system works. The inductor is connected in series with the voltage source which resists change of current. Thus the circuit is called a constant current source as well. So this circuit works in two modes. The first mode is switch closed mode where the switch is closed, and the second mode is when the switch is open. Usually we use a MOSFET or a transistor for using as a switch because we require very high frequency of changing the opening and closing the switch, which is not possible by any other switches. So we usually use a MOSFET. In this case, we have used an N-channel MOSFET. We'll come to a circuit later. Mode 1, when the switch is closed. So when the switch is closed, the voltage from the voltage source follows this part. It goes to the inductor where it generates a magnetic field around it. Then the current flows through the switch and back to the voltage source. Because of the low resistor path, this path is followed. Now why we use this diode? We use this diode because if we don't have this diode, the current from the capacitor will flow back from this path, and we don't want that, and we want the energy just to flow through the load. So we need to have a diode in this place. Mode 2, when the switch is open. When the switch is open, the main component, that is the inductor, which has stored the energy in form of magnetic field, just collapses, and that energy is provided to the load. It provides a current IL because it doesn't like the change. So we know that IL equals to V by R. V is basically voltage across the inductor and R is internal resistance of the inductor. Now since resistance and current are constant, the only thing which can change is the voltage. So in this case, a high peak of voltage is observed. The current flows through the diode, charges the capacitor, and goes through the load as well. Now coming to a boost converter circuit, as you can see, the main heart of the system is this 555 IC, which is giving the PWM signal. The 555 IC is working in a astable mode, and it has got 8 pins. The pin 1 is connected to the ground wave. Pin 2 and pin 6 are shorted together and also connected to the timing capacitor. Pin 3 is giving the output to our N-channel MOSFET. Pin 4 and pin 8 are connected together to the power supply. Pin 5 is helping in stabilizing the output, and thus it is connected to the ground through a 0.1 μF capacitor. It also helps providing immunity against electrical noises. Pin 7 is very important. It is connected to the inverted diode setup, and the junction is connected with the positive rail through a 1 kilo ohm resistor. So as we know that the main component of the circuit is also a switch, which is helping in all the operation. So the switch we have used is IRF Z44N N-channel MOSFET. The connection of switch are as follows. The signal from the 555 timer is coming to the gate of the N-channel MOSFET. Our drain is connected to the diode, and the source is connected to the ground. The duty cycle of our PWM signal is handled by this timing capacitor. This timing capacitor is connected to the inverted diode setup, and it's giving signal to pin 7. And how it works is that it gets charged from the main power supply through a 1 kilo ohm resistor, and the power follows this path. It comes through 1 kilo ohm resistor, then current flows through the diode, and then it charges the capacitor. The charge of the capacitor is given by TC equals to R into C, where R is the resistor, this resistance, and C is the capacitance of the capacitor. So by changing this resistance, we can change the timing of charging, and by changing the charging and discharging cycle time, we can change the timing of our PWM signal. Now when the capacitor discharges, it gives signal to pin number 7, which in turn gives a triggering to pin 3, which produces a square wave which is fed to the gate of our N-channel MOSFET, thus driving the switching. Now testing our setup. So this is our setup, and as you can see, we are using a 1200 milliamp hour battery with a nominal voltage of 3.7 volt. Checking the voltage of the battery, it is around 3.5 volt. Now testing the boost converter, we can see that while rotating the knob towards left side, the voltage is constantly decreasing, and we can increase the voltage, and the battery was charged around 3.5 volt, and we have increased the voltage to 6. We will go higher to around 7.5 volt. To read more details about this project, click on the link in the description below. That's all for today. Thank you.